In the first part, we are supposed to try to re-express this into its partial fractions, but the partial fractions has already been given to us. So of course, we can continue to try to re-express this, or another strategy will be to try to re-express the right-hand side to make it look like the left-hand side. So let's try that. So we have a 2 over x minus away 3 over x minus 1, then plus 1 over x minus 2. Let's try to combine this into one single fraction. So the common denominator will be x minus 1, and x minus 2, which means that this will be 2 times of x minus 1, x minus 2, and minus 3 times of x times x minus 2, then plus this will be x times of x minus 1. So let's try to re-express this. Expanding this, we are going to be getting a 2x squared minus 6x plus 4. This will give us a minus 3x squared plus 6x, and here we have a plus x squared minus x. This is going to be divided by this, which is x minus 1, and a x minus 2. So this here 2x squared minus 3x squared plus x squared gives us a 0. Minus x plus 6x gives us a 0, so I'll be left with just a 4 and then a minus x. So 4 minus x, this is going to be divided by this, which is x minus 1, and a x minus 2. And this is the same as the left-hand side, so we have shown part 1. In part 2, we are supposed to evaluate this summation, and we would definitely want to make use of the result that we have gotten in the previous part. So let us re-express this into this form. This is going to be equal to the summation from x is equal to 4 all the way until n. And re-expressing this, making use of the result from the previous part, it is going to be 2 over x minus away 3 over x minus 1 plus 1 over x minus 2. So we have this, and then expanding this into the method of difference format, we are going to be getting a 2 over 4 minus away 3 over 3 plus 1 over 2. And then letting x be equal to 5, we have a 2 over 5 minus away 3 over 4 plus 1 over 3. Letting x be equal to 6, we have a 2 over 6 minus away 3 over 5 plus 1 over 4. And we are seeing our first cancellation because 2 over 4 minus 3 over 4 plus 1 over 4 is going to be equal to 0. Let us write down one more row, and that is letting x be equal to 7. So we have a 2 over 7, then minus away 3 over 6 plus 1 over 5. So we are seeing one cancellation here, and we are seeing another cancellation here. So we are looking at a pattern that seems to be existing. We are going to verify this pattern of cancellation by writing down the last 3 rows, because 3 rows gives me one cancellation. So let's jump directly to the last 3 rows. That will be when letting x be equal to n minus 2. So we have a 2 over n minus 2 minus away 3 over n minus 3 plus 1 over n minus 4. Then letting x be equal to n minus 1, we have a 2 over n minus 1 minus away 3 over n minus 2 plus 1 over n minus 3. And lastly, letting x be equal to n, we will get a 2 over n minus away 3 over n minus 1 plus 1 over n minus 2. So we are seeing the same pattern of cancellation because this, and this can be cancelled. So this helps us to deduce that in between, all these terms here are also going to be cancelled. So we are going to be left with this, and if we were to evaluate this, we are going to be getting minus 1 over 6. And if we are going to be evaluating this is going to be giving us a minus 1 over n minus 1. And here we have a 2 over n. So this, I'm going to write it down here, 2 over n. This is going to be minus 1 over n minus 1. And like what I was saying just now, this, when we evaluate it, it is going to be minus 1 over 6. And now we have an expression that is similar to what the question wants us to show, because this is representing fn, and this here is the minus k, which means that comparing this and this, we know that k is going to be equal to 1 over 6. What we are supposed to do now is to try to prove that the summation that we have evaluated from the previous part is bigger than minus 1 over 6. And because in the previous part the question asks us to re-express the evaluated result into this form, we can see that there is this minus 1 over 6 in the previous result, which can be compared to this minus 1 over 6. So this is going to give us the hint, which means that what we need to do is to try to analyze this expression here, which by itself, it is not very possible, because, I mean, if n is bigger or equal to 4, then we are having one expression here that is positive, the other expression here together with this negative, this other expression here is negative. So it makes it harder for us to analyze. So what we are going to do is we are going to try to find some ways to manipulate this, and hopefully after some manipulation it will become easier for us to gauge whether we can then compare this entire expression to be bigger than minus 1 over 6. So let's take a look at this expression. Let's focus on this. What are the ways that we can make use of to manipulate this? How about putting them into one single fraction? So it is going to be 2 of n minus 1 minus n divided by n minus 1. And I'm going to leave this as it is. And this is going to be equal to 2n minus n. It gives us a n, then minus away 2. This divided by n minus 1 and minus 1 over 6. And this is good because for n to be bigger or equal to 4, this was already given to us by the question. For n to be bigger or equal to 4, we can then analyze and see that this expression here, n minus 1, it is an expression that is going to be bigger than 0 all the time. Because if n is bigger or equal to 4, let's say for the numerator here, it's going to be 4 minus 2 is positive. This is positive, and this is 4 minus 1. It is going to be 3. It is going to be positive, and n is just going to be bigger than 4. So it will be 5, 6, 7, and it is always going to be positive. So this expression here is bigger than 0 all the time, which means that if I were to minus 1 over 6 on both sides, n minus 2 divided by n minus 1, I will minus 1 over 6 on the left-hand side, and I will minus 1 over 6 on the right-hand side, then we show that this expression here is always going to be bigger than minus 1 over 6. And what is this expression representing? It represents the summation. So we can therefore say that the summation from x is equal to 4 all the way until n of 4 minus x over x minus 1, x minus 2. This is going to be bigger than minus 1 over 6. Here we are supposed to evaluate a new summation, but if you were to look at this summation, it looks very similar to the previous one that we have derived. So we definitely should try to make use of the previous result. In fact, we are going to make use of a strategy that we have discussed on Achievers TV, which is to replace r by r plus p strategy. So I'm going to apply it here, but not immediately because the denominator here is so jumbled up. I think that is the trick that is imposed by the Hwa Chong question here. So if you were to look at the previous part, the denominator is expressed very nicely in descending in descending order. So x minus 1 is smaller than x minus 2. So we're going to try to re-express the denominator first so that it is also in descending magnitude. So this 3 minus x, I'm going to leave it as it is, which is the biggest one. X plus 1 is the biggest. So I'm going to write x plus 1 first. Then the next one is going to be x. And the last one, the smallest one, is going to be x minus 1. And now we are ready to re-express by observation. We can see that as long as I can replace this x here by x minus 1, this will become this will become this, and this will become this. So let's try this. I'm going to replace x by x minus 1. So according to the strategy that we have on Achievers TV, if we were to do a minus 1 here, we are going to be doing a 2a plus 1, the opposite of what we have done here. And all these x here are going to be replaced. So I'm going to be replacing this x by x minus 1. This is going to be divided by x minus 1 plus 1. It's going to give me an x And this x is going to be replaced by x minus 1. And this x is going to be replaced by x minus 1. So we have x minus 1 minus 1. That gives me a x minus 2. So now we have a summation minus 1. I'm going to bring it over to the other side of the equal sign. It is going to be equal to a plus 1. And here we have a 2a plus 1. This is going to be 3. No, it is not 3. 3 minus minus 1. 3 minus plus 1 is going to give me a 4. So here it's going to become a 4. So 4 minus x. This is going to be divided by this, which is x. X minus 1 and x minus 2. And now the expression that is within the summation is exactly the same as the previous part. We can then make use of the result. And again, because this number here is different, we are going to make use of another strategy that we have highlighted on the Achievers TV. So I'm going to apply that here. I'm going to sum from 4. Okay, the inspiration comes from here all the way until 2a plus 1 of 4 minus x over this, which is x. X minus 1, x minus 2. Then our minus summing from x starting from the number 4 all the way until one term that is before this, which is a. Then I'll use the same expression, 4 minus x over x. X minus 1, x minus 2. So if we were to sum from 4 all the way until 2a plus 1, minus away 4 all the way until a, we are going to be left with a plus 1 all the way until 2a plus 1. So for this, now I can make use of the previous result, replacing all the n by 2a plus 1. So we have a 2 over 2a plus 1. And minus away, replacing this n by 2a plus 1 gives me a 1 over 2a and minus 1 over 6. Then minus away, replacing all this n by a, I will have a 2 over a minus 1 over a minus 1 minus 1 over 6. And if you were to evaluate this, you will be getting a 2 over 2a plus 1 minus away 5 over 2a and plus 1 over a minus 1.